Yes, Inish. Okay, can you hear me, Inish? Inish, can you hear me loud and clear? Testing. Inish.
Hello, I can hear you.
Good. All right. Don't have to shout. Normally, can you hear me?
Hello.
All right, good. All right, good. All right, okay. I'm just telling your father that I can hear you already. Okay. Okay, Inish. Normally 1 week 3 hours, right? But this week I have to relocate from Batam. I'm in Batam right now, to Singapore. The relocation, I'm bringing my wife, my little baby. They'll take some time. So I think for this week we can only meet 1.5 hours, and that is today.
Oh, sure.
Okay. So now, do you have just a minute? Yes. Okay, never mind. Right. So do you have any math homework? Like, I know you usually don't have homework, but maybe you have today?
As of today, no. I actually do have homework that's being assigned on Wednesday, but there is no tuition session then. So.
Is it math?
Yeah, it's math.
It's logarithm, maybe?
Yeah, it should be about logarithms.
But you don't have it right now.
No, it's online. It'll be assigned on Wednesday.
So how does your school work? They assign you on Wednesday and they expect it to be completed by?
No, you see, this Wednesday, it's called Blended Learning Day. It's a thing exclusively to STF. So every alternate week, we stay at home and we do online lessons instead. So instead of online lessons, our math teacher prefers to give us assignments.
Oh, right.
It'll be due on the Wednesday itself, the same day.
So it's always Wednesday, but alternate weeks.
Yeah.
Okay. Right. Okay, never mind that. Right. So Aditya, I was saying to you and your father that we cannot bet on a lot of improvement this coming mid-year or SA1.
Yeah.
Right. So, but I do notice that you are studying you are starting to study logarithm. You're not very far into it yet, right? So usually to help students catch up, let's say we're interested in catching up to math. It's not a very good idea to study the past topics. That's not the only way to catch up. The reason is because if you study that, you still have to study the current topic, and there's also future topic to worry about. So if the past topic is not helping the future topic, it's not the best use of time at the start, right? At the end, we have to study them, but at the start, I don't think so. Yeah. So I noticed that logarithm is still a new topic, still a fresh topic. So one possibility today, Inish, we're gonna study logarithm beyond the class, and then we can have some expectations about logarithm, right? Okay. That's one possibility. Another possibility is that we simply study the term 3 topics. In SGI, do you call it term 1, term 2, term 3, term 4?
Yeah. Yes, we do.
So another possibility is that we just forget about term 1, term 2 for a while. We are forgetting about SA1 totally, and we just focus on the future one, which is term 3. But term 3 is still 2 months from now. So I don't think that's the best option, but we have that option. Right? Obviously, the third option is we just start from term 1. That's the usual option. I don't like that option at all, however. What do you choose, Inish?
Obviously, it's between the first and the third, because I don't want to just basically I want to do well for everyone as well. Not well, but I want to be able to do
something, right? Then the way to start, in my opinion, is to start with logarithm.
Okay, sure.
Right. We'll be touching on in this because it's logarithm, but we'll be touching it because we need it in logarithm.
Okay.
Okay. Now, with that settled, I'm going to tell you the downsides of studying logarithm, right?
Yeah.
So that you are prepared. So logarithm is presented very abstract. It is not presented in a way that is very meaningful. And so as a result, sometimes you will feel that you have to memorize a lot of rules. I'm trying my best to minimize that. I'm trying my best to make logarithm understandable, right? So in general, that's how I want your A math to be, something that you can understand, and hopefully the enjoyment will follow. Yeah. However, we're starting with logarithm, one of the more abstract topics of term 1 and 2. So that's a little bit unfortunate, but we'll do our best. Okay, now, Ines, we're going to use the Jamboard from the trial, right? You still have it. So please access your Jamboard. I'm going to put this today's date.
Do you want me to create a new one?
Do you want to?
Yeah, sure. It'll be easier for organization.
All right. Okay. Now, keep the formatting like this. So the date and then your name, the minimum. Then you can write other things. Why is that important? Because for me, I have many students. So obviously your name is not important for you, but it's important for me. So keep the formatting that way. Yeah. Okay. Now, once you have shared with me, please tell me so I can access it.
All right. Today's date is
18, I believe.
Yeah.
Right.
Your email. Okay. Do you want? I have the syllabus with me as well. Do you want me to?
You can WhatsApp me. Do you have my WhatsApp number?
No, I don't. But I can email you.
Email too slow. I give you my number, Chris. Then you can edit me. Then we can talk to WhatsApp. So my number is +65 9382
9382
1791.
1791. Okay, thanks.
All right. Okay.
Yeah, give me a second. Let me walk.
No problem.
Yeah, I've shared the board with you already.
Okay, that makes sense. Excellent. Okay, Ines, remember the handphone stand I was showing you?
Yeah.
Yeah, I sent it already, but it'll probably arrive in 1 to 1.5 weeks. So just telling you that.
Okay, sure. Okay. Wait, are you on WhatsApp? Did I get your number wrong?
I am in WhatsApp and I'm online. Check my number again. Positive +65, right? So 9382.
Yeah.
1791.
Oh, I typed it wrong. Okay, my bad.
Oh, right.
Yeah. Yes. Okay, there seems to be a technical issue. I'll send it to you later if that's okay.
No problem. No problem. Right. No worries. Okay. So in Jamboard page 1, this is 1-to-1. We're not going to always do 1-to-1 at the start, right? So this is an opportunity to go hard and fast, but how do I say this? Don't keep your questions. Ask them immediately because this is 1-to-1, right? I can answer your question, and I don't have to worry about other people's question. Entertain your doubts, clarify anything that seems unclear, and don't settle for shortcuts. Understand?
Okay.
So even though I'm going hard and fast, I don't mean that we should be rushing. I mean everything should still be reasonably clear. All right. Okay. Now logarithm. How long have you been studying logarithm in your class?
Not even been a week yet. So they
Okay.
already know.
All right. Okay. Good. Now, now I'm gonna do something. I'm gonna share you my screen. I guess we'll start there. So first time I'm sharing. So when I'm sharing you my screen, we focus on my screen for a while and not on the Jamboard.
Oh, on your screen. All right.
Right. So you can see my screen. There's a lot of graph going on, right?
Yeah.
Right. So y equals to 2 to the power of, where's power? Power of x, right? Now, have you seen the shape of this is so-called in this graph before?
No. I think so, but I didn't really understand.
Right. However, it's not a very complicated shape, is it? It's steadily rising. Particularly, this point is important. This is at x equals to 0, the y is 1. That's easy to see because 2 to the power of 0 is 1. Right? Easy to see. So it steadily rises after that. And when you go to negative, it's steadily decreasing, but it never actually crosses the x-axis line. It never. So it never goes to negative. Right? So this is sometimes why your teachers say, you know, it cannot be negative. What he means is something like this graph. Okay. Now I'm going to take liberty. You were saying? Sorry, you're saying?
But why is this the case? Why doesn't it have to
count? Right. Okay. So before that, I'm enabling annotation. So you know in Zoom you can annotate, right? So in case you need to annotate. Do you know the annotation function in Zoom?
Oh yeah, I think so.
All right. Just try in case you need to annotate. The press annotate button and you can write on my screen. In your Zoom menu, I have enabled annotation. Try to find that annotate menu. If you cannot, please tell me.
Oh yeah, it's not here.
Okay. Your Zoom menu should be like a green bar, right? And then there are, all right. Then there's three dots and there's annotate, and then you choose draw, and then you draw something. I can see you drawing on my screen. Please give it a try. Okay, good. See, I can see that you're drawing a circle. So I can do the same. So for example, I'm drawing a triangle. Okay, so let's clear the drawing first, right? Okay, now back to y. Okay, excellent question. Now, in fact, I'm going to do something more. I'm going to change this 2 into a because I can do that. And then this a means I can change it to whatever number I want. For example, in this case, my a is 2, right? So in Desmos, you can do that. But you can install Desmos in your phone, iPhone, anything you want. These things are common, right? Now, notice a few things. Inesh. If I change the a to, for example, 5, right? 5. Where's 5? That 5, right? Notice that the general shape of the graph never changed. Correct or not?
Yeah.
Notice that it never crosses the negative line.
Yeah.
And notice that the 1, 0 is still 1, 0.
Yeah, is that a rule?
Sorry, you're saying?
Is that a rule that every single graph?
No, don't memorize. Understand the reason why. Y is x equals to 0. Y is always equals to 1. You can see it immediately here. 5 to the power of 0 is
1.
2 to the power of 0 is
1.
Half to the power of 0. Let's say half. Let's say half.
1.
Half. So is that a rule or is it something that you can understand?
So basically anything to the power of 0 has to be 1.
If that is the rule that you're saying, well, that's true. That's true. That much is true.
Okay.
That much is true, right? Okay.
So then,
yes.
You're assuming here that x is a 0 because x hasn't been defined.
Because I'm pointing out to this special point. This special point does exist in this graph. If it is 0, comma, always 1. I'm going to make it very clear. I'm going to make it very clear by doing this. Y, copy that. So here I'm going to put it as 2, right? So I'm going to ignore red for now. Okay, add a few more. Let's say, give me a random number.
6.
Right, 6. Okay, there you go. What is this point? 1, 0, 1.
Yeah.
Give me another random point. A
7.
random number. 7. No, a fraction, for example.
Half.
Okay. There you go. The graph seems to flip, but the 0, 1 stays.
Okay.
Give me a negative number.
-5.
Right. So I'm going to type that with a bracket, -5. Okay. Where is the red? Oh, they cannot. I'm sorry. This is not part of the syllabus. My apologies. So at this point, I'm not saying that -5 cannot be power x, but it is not in your syllabus. It's not that it is impossible to do, yeah, very different, but it's not in your syllabus. So the bottom line only positive, right? So here's your famous 0, 1. Visually, I think it's easy to remember, but I hope you also know the reason why. Now, do you know the reason why?
Like you said, it's because assuming that x, like seeing that x isn't assumed, it has no value, so it's 0, and anything to the power of 0 is 1.
Is always 1. Hence the special number, right? However, I have not answered your first question. Your first question is, why can't it cross the negative? Like even with 2, with 6, with half, it never actually crosses the negative, the x-axis, so to speak, right? So because I am going to, okay, I'm going to use annotation. Remember when we talk about this seems to be confusing back then. To the power of, I'm sorry, I shouldn't use y equals to 2 to the power of -1. -1 seems to be something that is difficult to imagine. And then I say, you should think about it as that. Do you still remember?
Yes, from what we learned here last lesson.
So for some reason, a minus in this, a minus power is best represented as the guy below, the denominator guy, right? So I put this as 0 -1. So here's your 2 to the power of 0, which is obviously equals to 1. There you go. Yeah. Right? So now let's deal with, for example, 6 to the power of -3. What is the best way to imagine this?
Should be
the guy below, right?
Yes, 6.
Something like that.
Yeah.
Right? And what is this? Well, this is this. It doesn't matter though. Now, my question is, this guy is negative, but the meaning is best represented this way. Is it possible for this guy with the power of -3, -4, -5, whatever, minus value, is it possible for a minus power to give you an actual minus number?
No.
Let's try that out. Give me a random base number.
4.
Okay, 4. And then a random power number, but negative lah.
-3.
All right, -3. Is this a negative number actually or not?
Should I calculate?
No. This one, don't use calculator. This one, of course, you can always use calculator, but don't. I want you to understand. What can you do? How can you imagine 4 to the power of -3?
So it should be 1 by 4 to the power of 3.
At this point, are you convinced that this is not negative?
Yes.
It's just small though. It's smaller. It's small.
Yeah.
Like, what is this? This is 64, I think, 64. Now, the point is, it's just small, but it is approaching 0, but it is never less than 0.
Oh.
This is answering your first question. This is answering your first question. When you change the x, which is in this case, the power, right? The power. You can make the power -16. You can, if you wish to, you can. What happens when you make this 4 to the power of -16? Well, it simply becomes a number which is smaller and smaller and smaller, but never truly approaching 0.
Oh.
And it is obviously never negative also.
Okay.
Right. So there is now a new sense in you. If you're learning in this at the initial stage, there should be a sense in you that if it is a power negative, it does not mean a negative value. It does not mean that. Okay, Kenya. Now, any other question?
No.
Right. Now, I'm going to show you a logarithm. Yes, you say?
Oh, you erased that?
I want to show you a logarithm graph.
Yeah.
Right. So in our trial, you learn that in this is somehow related to logarithm. In fact, that's why you study them back to back. Now I'm going to show you the relationship visually. Right?
Can you give me like a minute or so? I need to copy all this down.
You want you want to write a note? Yes, please go ahead.
Yes.
You tell me when you're done, and I'm always happy to give you time.
Okay, thank you.
Yes. Okay, I know I have your WhatsApp here.
Thank you. But any negative fraction to the power of 0 is also 1, right?
Repeat that question, sorry.
Any negative fraction to the power of 0 is also 1, correct? Just making sure.
Okay, let me confirm what you mean. Do you mean that, for example, half, negative half, for example, to the power of 0?
Yeah.
Yeah, equals to 1.
Okay.
I suppose you can treat it as a ruler, I suppose. Yeah, okay, sure. Oh, right.
And so just to be sure, anything to the power of 0, anything to the power of 1, anything to the power of -1, all equals to 1.
No, wait. Anything, so anything to the power of 0 is 1. Yeah, okay.
Anything to the power of -1, positive.
Anything to the power of -1 is positive. No, again. Sorry, yeah. Okay, let me try to illustrate that. So if, for example, this is 2, yeah, okay, it's positive, right? This is positive, and this is also positive, right? However, sometimes, very rarely, you will encounter this. This is not supposed to be in syllabus, but you will encounter this sometimes. So this will be like that. So this indicates this negative and this negative. However, this is formally in syllabus, and this is for some reason not in syllabus. So what you're saying is true just because of the syllabus limitation.
Okay.
Right. Is you're saying another thing? You're saying something else? Sorry, just
everything to the power of 1 is also 1, correct?
No. So 2 to the power of 1, it is something that you have been writing all along. It's 2. 3 to the power of 1 is something you've been writing along. You never bother to write the power because you don't need to.
Oh, okay. Okay.
Right? Anything to the power of 1 is himself.
Okay. Okay. Yeah.
Now, please notice in your FX96, right? You have it with you? A dedicated button for power -1. You have actually a dedicated button for that. Please notice that.
For power, yeah.
Yeah, power -1, not just power, power -1. Do you see that? I want you to find the button. It's above the button, so I think it's above the button. I think. If you cannot, you're gonna take a picture. Might as well, right? You use your WhatsApp, take a picture, and I'll show you where that button is.
-1.
Yeah, power -1. Right? If you cannot,
okay. I found it.
I found it. So you try lah. For example, here's a random number like 363 to the power -1. What will happen to 363?
1 by 360.
1 over 363. So that's just what power -1. Okay.
Yeah.
So far so good. Yeah. Any other question?
No.
All right.
Actually, I do have a question, not related to this, but in general.
Yes, please.
Do you know how to operate the graphic calculator?
Roughly, I know what to expect, but I sometimes need you to try it out.
Okay.
Why do you ask? We will be using it quickly, like after this topic, I believe.
Yeah, that's why I'm asking, because it is pretty heavily used in school.
Very good. And you should learn how to use it to your advantage. It is a useful thing. Never mind the fact that your half of your exam does not allow you to. Never mind that. Just forget about it. In fact, I'm going to do in Desmos, you're seeing my screen, right? This is Desmos, isn't it? Now, Desmos is just a representation of your graphing calculator. Whatever I can do in Desmos, you can do in your graphing calculator. It's slightly harder to use because of the button and the menu, but he has the ability to do, for example, to plot the graph of logarithm. The base, I need to find the logarithm base. Yeah, wait. Here. Okay, so log base 2. There you go. Notice that our blue graph is 2 to the power of x, and therefore my logarithm graph is log base 2, whatever that means, right? Do you notice something about these two graphs visually? Do you notice anything about these two graphs?
Yeah, they look the same, just inversed.
Kind of like that, right? I'm going to point out a point for you. For example, remember this point is 0, 1, right?
Yeah, that'd be 0, -1.
No, here you go. Here's the sister point. I'll call this the sister point. And the sister point is 1, 0.
1, 0. Oh, right, my bad.
Right. Visually, again, I'm asking you to see this visually, not mathematically, so to speak. So this point, what is this point? This fancy point is 2, 4. Yes?
Yeah.
Can you predict the sister point?
4, 2.
4, 2, which is here, right? 4, 2, which is here, right? The end tail, this tail, never approaches the x-axis, right? It's just slightly above. This end tail never approaches, never touches the
y-axis.
It is just slightly approaching it, but never.
Yeah.
Those are not coincidences. They are really there because this is what we will say. Logarithm is an inverse of indice. That is their relationship. That is the relationship. Now, I'm going to show you one more graph. Now, this is the graph. Now, I'm claiming, I'm not explaining, I'm just claiming that this purple line is the mirror that connects them. So this point mirrors himself through that line into this point, right? This point, which is a bit weird, -4, 0, 0, 6, 3, mirror himself to this point, which is, 0.0 63 minus 4, something like that. A bit difficult to pinpoint, a bit difficult to pinpoint. Somewhere there, all right? Somewhere there. Okay?
Yeah.
Now, so Ines, visually, logarithm is the inverse of index. Visually, right? Now, give me a random number.
3.
Okay, so let's put this as 3 to the power of x. Oh, it's not very clear, is it? So I don't like it. Make it bigger. Make it bigger.
9.
Okay, 9. So if I put 9 to the power of x, now you start to see that 9 to the power of x is no longer the inverse of logarithm base 2. You can now see that visually, yeah? Now I'm going to change this to 9. So tell me what will happen if I change this to 9.
Will mirror again.
There you go. Can you see it?
Yes.
Right, so just to prove it, what is this weird point? There must be a data. This is 0.1,9. Yeah. So the sister point will be
9,1.
So let's see that. There you go. There you go. 9,1. Yeah. Okay.
Yeah.
So this is our start to logarithm. Now I'm gonna go back to Jamboard and I'm gonna stop sharing. Okay. Again, whenever you have any question, just help. This is how logarithm standard logarithm works. 2 to the power of x equals to 5. Why do we need to use logarithm here, Ines?
Sorry?
Why do I feel the need to use logarithm in this situation?
What's the situation?
Oh, this is this. Oh, sorry, in Jamboard page 2.
Oh, okay. Jamboard.
Page 2, yeah.
Yeah.
Right,
Okay.
Here's the situation. 2 to the power of x equals to 5. Okay, if you try using your calculator, there's no nice number for this guy. Never, not going to happen, right? Now, why do I feel the need to use logarithm in this situation? This looks like in this situation. Why do I feel that need to use logarithm?
Because we have to get x and
Yep, this is what I want, right? X equals 2, right? So
yeah.
How do you dethrone x from its position of power to here? How do you do that?
Log it.
Yeah, and particularly log has a base. You must mention specifically the base as base 2.
Yes.
Door, whatever you do to the left, you do to the right. So what is x?
You mean the calculator?
No, I want you to mention this.
Yeah, okay.
So as a revision, what happened on the left-hand side?
The log basically brought down the 2 and then the x.
So what happened to the log himself, the base 2 of the log, and the base 2 of the index? What happened?
It got cancelled out.
So to speak, but you cannot officially say that, and you cannot officially do that. But inverse is like that. Look, this log meet this guy, they disappear, leaving x for you.
Yes.
Okay, now I'm gonna put you another situation. Okay. Log base 2, give me a random number.
3.
3 equal, oh no, you cannot. I'm sorry. I'm gonna put x here because it's easier. Right? So inside x, that equals to 3. Right? Now, how do we find x?
How do we find x?
The x is locked inside a logarithm. How do we free the x from the logarithm? How do we do that? What is the inverse of logarithm is what I want you to see. Very good. So I will apply index. Watch. 2 to the power of that. 2 to the power of that. Yes, I just applied index to the question. Why do I do that? Because in the same manner that log base 2, they quote unquote cancel, leaving you with x. 2 to the power of log base 2 will cancel, leaving you with x. It works both ways. Okay, it works both ways. So 2 to the power of 3 is the answer. How do we prove that? We go back to the original, log 2, and the x will be 2 to the power of 3 according to our working, yes? What is log base 2, 2 to the power of 3?
It should be 3.
And voila, you see why x should be 2 to the power of 3.
Oh, okay.
All right, make sense so far? This is the relationship between indice and logarithm. This is the most basic thing.
So basically,
Yes.
actually, I don't get it. Can you just redo that again? Just
In a different setting, right? Give me a random number.
okay. 4.
Okay, go to page 3, by the way. Yeah? So 4. I'm putting 4 as the base. Give me a random number. No, I'm giving you an x here. Give me another random number.
2.
2. No. Something not so nice.
Something not so nice. Okay, a 5.
A 5. Sure. How do you find x?
Okay.
How do we do it? You tell me, I'll do it for you.
So we have to use indices here.
How do we dethrone the x from the indice, not by indice? How do we dethrone the x, which is in the position of power, from the indice? Not with indice, but with the inverse of indice. Because you want to cancel the indice, isn't it?
Yeah.
What is the inverse of indice?
Logarithm.
So I need to apply logarithm to this indice, but logarithm has a base. I have to set the base properly. What is the base of the logarithm?
4.
Log base 4, applying it here, and then dot, whatever you do to the left, you must do to the right. So also log base 4. What will happen next?
X equals to the log base 4.
Whatever this weird number is. It's a weird number, but you're correct.
Oh, okay.
Okay. Now I'm gonna apply the other way. Log base 4x equals to 5. How do I free the x from the logarithm?
Now here you use indice.
Okay, so what kind of indice, base meaning base, should I apply here? Remember, indice has a power and a base, right? So how do we apply indice here? Yeah, this is gonna feel weird. Yeah, I'm gonna show it to you again. This is weird. I'm not saying that it's not weird. Truly weird. I set the base of the indice as 4, and this guy is the power of the 4.
Oh, why is that?
Like that. Okay.
Why does that have to be? Is that?
I will show you. But first of all, I will tell you the result of this first. The result of this, that the indice and the logarithm cancel each other because their base matches. You will be left with x equals to 4, 5. Again, I would like to show you in 2 ways why this answer is correct. Then you can probably see why this makes sense. Because right now it's very weird, right? Because if you put this here, correct? If you put this here, it's 5 what? Correct?
Yeah.
See? I'll show you another way. It's very interesting. Huh? I'll show you another way. I'm going back to here, right? Remember that the x is this weird number? Remember?
Yeah.
Right? Remember? So what we are saying is that 4 to the power of log 4, 5 is 5. That's what we're saying, isn't it?
Yeah.
So isn't what we are saying here is this cancels that, so to speak, because 5 then equals to 5. The same thing that's happening here, right? The same thing that's happening.
Log 4 cancels 4.
This one, log 4 cancels 4. So x equals to that, right? But I am reapplying the answer back to the original, right? I'm just doing that. I'm just applying the answer to the original. I'm replacing the x with log 4, 5. Hey, 4 to the power of log 4, 5 is equals to 5. Oh, that means this is canceling each other.
Yeah, okay.
So that's how they work. As weird as it is, that's how they work. So we're interested in logarithm because it is the inverse of the index. Why is it very interesting to have an index? To have an inverse? Well, you will see the usage later, but it is very important to have the inverse of a function. It is important. It's just that they don't tell you that way right now. They just tell you, go and study index, then go and study logarithm. But they have a strong connection, a very strong connection, right? Are you clear? Do you want to have time to write something here first?
No, I mean, over here is the whiteboard. I can just refer to it when I'm trying to make.
Okay, very good, very good. Treat this
I do have a
as
question though from earlier before we moved on to the whiteboard in the graph.
yes.
Do you happen to still have the graph page open?
Oh, wait, sorry. Sorry.
The graph page open, yeah.
You mean this graph? I'm sorry, I'm not showing you the screen. So I'm sharing your screen again, right? Sharing screen. So are you referring to this graph?
Yes.
Now, this graph does not exist in the Jamboard, unfortunately. So there are a few things I can do. I can copy this and put it in the Jamboard, but it will be a dead picture. You cannot manipulate. The only way for you to access this is to go to Desmos yourself. Why don't you do that, right? Why don't you go to www.desmos.com? Do it, right?
I think my calculator is the same functions, but I'll just
your calculator can do this, yes, of course. Right. So I cannot put the Jamboard damper in the Jamboard unless I copy. So I'm just going to do that for you. I'm going to copy Desmos into the Jamboard. Then I'm going to put that in page 4. Right. For now, that's the best I can do. Okay.
Is it possible to work on the Jamboard like at the same time?
You mean to look at my screen sharing and to look at your Jamboard at the same time?
You know, like we're doing in the Jamboard. You edit, I can edit. Is that possible to do in Desmos?
No, Desmos is not that good. So the only way to do that usually is using annotation, which is not really editing the Desmos. We cannot do that. Can't do that. For now, we cannot. For now, we cannot.
Yeah.
Right. So a bit of a technological limitation. Okay. So I'm going to page 5, but any other questions so
far? No.
All right. Now, from now on, the logarithm will take a slightly abstract feel. Until just now, 45 minutes into our tuition, I have been trying to make sense of logarithm for you, and in this for you, and their relationship, right? So they shouldn't feel abstract. They should feel that they have some meaning to it. But from now on, it'll take a slightly abstract meaning, and I will try to ground them back. I'll try to always give them meaning. But unfortunately, this is how they teach logarithm. It's weird, right? So I apologize for logarithm beforehand.
Yeah.
Now, they will start early on the rules. There are only 3 rules or 3 laws, but the 3 laws are very you're saying? Can you hear me? Sorry.
Yeah, I can hear you. What I mean is that can you give me like a minute? I haven't eaten dinner yet, so I just want to ask my mom.
Yes, please. Tell me when you're back.
Yeah, it'll just take me a minute. I will tell my mom.
Sure.
Yeah, okay, I'm back. I actually haven't eaten lunch yet either. This is a combined meal.
You haven't eaten lunch?
Oh, yeah. I usually eat 1 meal after school.
Why do you not eat lunch, Ainesh?
I come back from school at about 4:35, and today I had to stay back.
You don't have time to eat lunch in like 12 p.m.?
No, we just have one recess period.
So you mean you have breakfast at 6 and then you are now at 9, you're just eating your next meal.
I mean, I had recess, but yeah.
Yeah, go ahead and eat while having tuition, as long as you can think. In fact, if you're hungry, you cannot think, right? So I'm fine with that. Right?
Thank you.
Right. My goodness, right?
It's fine.
But if your primary 3 is not fine, right? But you're not. Okay, fine. Logarithm will take a slightly abstract course here. They will introduce this as rule or law. There are 3 rules or 3 law. They introduce this very early in logarithm, and they expect you to be able to use them perfectly, even though they are very abstract. So again, I'm going to apologize on that. Right? So you have your FX96SG. Yeah. Now, notice in your FX96, you have 2 logarithm buttons. You have, I think they write down as LOG, if I'm not mistaken, and then you have LN.
LN?
Like LN is very close to LOG.
Oh, that's LN. I've been thinking it was
IN. Turns out that is LN, right? So let me tell you what LN and LOG mean. This is where we have to have an agreement. LOG actually means log base 10, 10 being a useful number. Your teacher will write this down as LG. So one more time, your calculator right now is LOG. It's not your normal LOG. It's LOG base 10. And your teacher will likely write down as LG instead to differentiate it from other LOG, because clearly your logarithm can have other bases. It can. So your calculator is a bit misleading that way. It's actually LG. I'll just put the most modern way of expressing it. Okay, your calculator is actually an LG, logarithm base 10. Okay, now LN is fine. LN is going to be logarithm base natural number. You have not seen this number before. You have not seen it. Am I correct?
Yeah.
This number is one of the most important number, and yet they never explore it in O level. I don't know why. In IP, right? Never. So I'm going to invite you to find the letter E in your calculator. Your calculator has a letter E.
Small letter E?
Small letter E. I'm going to ask you to do that. It's almost as even as pi, right? If you press pi in your calculator, you have 3.14142, whatever, something. Now, if you press E, you have 2.71 something. So kindly do that.
Yeah.
Have you found it and discovered 2.71 something? Okay, this E, which is your first introduction, is called a natural number. Is a natural number for a very important reason. The reason that they don't talk about. I'm so sorry right now. I'm so sorry. Yeah. So E is an important number that they immediately going to use in logarithm. For some reason, logarithm base E is important besides logarithm base 10. They give you 2 dedicated buttons in your calculator.
Okay, so let me get this. Log 10 is the same as LG.
In your teacher's writing, but not in your calculator. So your calculator is a bit misleading.
I don't have LG.
Yes, but your LOG button is LG. Is log base 10. Just want to say that.
Okay.
Your LN is logarithm base. Now, here's a simple question. Where is logarithm base 2, for example, in your calculator? Sometimes you need logarithm base 2, right? Sometimes you need them. So where is it?
Are you?
Yeah, you don't have. You don't have. Where's logarithm base 4? When you need it, you don't have it. Where's logarithm base 5? When you need it, you don't have it. You
Yeah.
only have base 10 and base e. So here is the first law of logarithm that I want you to learn. The first law of logarithm bypasses this limitation. So if you learn the first law of logarithm, you can survive by using this button and this button, even though you need this. Okay, so here's the first law. The first law will not make sense, but it is very useful. Here's the first law.
I'm still not clear about the LG and log thing. So we've been using log all this all, right?
And you have been actually using log base 10, not log. There is no such thing as only log. A log must have a base.
So then in our calculator, the log we're using is not log base 10, it's just log.
So are you referring to your GC, the fancy one, or just your FX96?
The FX96.
The FX96, when you see log button, it does not mean log. It means log base 10, always.
Okay, so
all right. Okay. Yeah, always. For example, try your log button and put 100. Just put 100 there. Just give it a try.
I got 2.
Yeah. Now, why does it give you 2?
Because it's a 10 thing.
Because 100 is 10 to the power of 2.
Oh,
the log base 10 cancels the 10, they give you 2. So that's a proof that this is base 10. It's a proof.
Okay.
If this log is base 2, for example, base 2, 100, you will not get 2. You will get a weird number. But it is not base 2, right? Now, let me... Sorry, you're saying?
Yeah, but it's not possible to change it.
It is not possible in your FX96. And that's why I have to teach you the first law. Later. I'm going to give you a proof that ln is log base e. Now, you try ln e to the power of 3. Try that.
ln e
to the power of 3. Your answer will be
3.
As expected from a log base e. The log base e will cancel the e, right? As expected. Just give it a try. Logarithm log, which is lg basically. Lg e to the power of 3. Let's see what happens. Your lg is your log, your so lg e to the power of 3. So what happened?
It's a bunch of decimals, 1.30.
Right. This is a proof that lg base is not elo. That's a proof.
Yeah, so it's not the same.
It's not the same. LG and LN is not the same. Now here's another proof. Let's say LOG, again, your button LOG, which is LG. You try e to the power of 2. Try LG e to the power of 2. Is the answer 2 or is it something else?
It's 0.86.
Yeah, my point is LG base is not elo. That's my point.
Yeah.
It turns out to be that. Okay. So I'm glad I cleared that from the start. You mean your teacher doesn't say this?
I mean, like I said, she goes through really fast, so I don't really get anything actually.
So I'm very slow, which is good, I suppose.
No, you're not very slow. You're normal pace.
Right, normal pace. Now, let's start with the first law. The first law is meant to circumvent this problem. Your calculator limitation must be upgraded, right? So look now. Let me illustrate the first law. The first law is allowed to allow you to handle base 2, base 6, base 5. For example, the answer to x is log base 2, 5. Big problem. You only have base 10 and base e, correct?
Yeah.
Now, observe this. Here's the first law. The first law in action. I am claiming, Inesh, that log base 2 of 5 is going to be equal to log base 10, 5 over log base 10, 2. I am claiming that.
Okay.
I am also claiming, still the first law, it is the same as log base e, 5, log base e, 2. I am claiming that. And I'm also claiming, if you so wish, give me a random number.
7.
7, right? 7. So it is also going to be equal to log base 7, 5, log over log base 7, 2. I am claiming that. That's the first law. No explanation given, but I'm claiming that this will be correct. Just a quick introduction how the law works. I want my base to not be 2. So happens my calculator have base 10 or base e. So I can do a base change. No? I can change the base 2 into base 10, keeping the 5, but over log base 10 also 2. Totally weird. Doesn't make sense, but it'll work.
Okay.
I don't have to stick with 10. I can stick with E and E if I so wish. I can stick with 7, 7. So wish, I can stick with anything I want as long as they are the same. Okay, so now, would you please press the calculator log base 10, 5 over log base 10, 2. Would you please do that?
Log base 5. Log 10.
No, you'll get a very weird number.
I got a syntax error.
Could you take a picture of your calculator and then show it to me? This is important. Just send it using the WhatsApp.
Yeah, because by log 10 you mean just the log on my calculator, right? So
yeah, only that. You don't have to. Yeah, show me a picture. Send it to the WhatsApp.
Okay.
I don't mean take a picture of the syntax error. I mean take a picture of your typing before the syntax error. You can just press the up button. You need to close the bracket for them both.
Oh.
Right.
Oh, okay. 2.32.
Right. So I'm claiming, but without proof, that this guy in your calculator is going to be equal to this guy. You cannot press this guy in your calculator. So currently my claim is just my claim. Now I'll show you some possible proof to my claim. Now kindly type this thing. This is ln, right? Log base is ln, right? So kindly type ln 5 over ln 2. Please compare the answer.
Wait. Wait. So
what's your problem?
So ln is a log, then
log base e, right? ln is already log base e, so the base is already in, right? So ln
you
5.
can't actually edit.
You cannot change the base, yeah. Same like LG or LOG. You cannot change the base. It's forever 10 in your calculator.
Okay.
So they don't even bother to show it. It's actually there. But they don't bother to show.
Yeah, I got the same result.
Right. So this is a slight proof. So at least you can see why this is correct, right? You can see why this is correct. Now, kindly try using 2 different numbers here. Just confirm one more time to satisfy, right? Maybe you put this 4, you put this 7. I don't know. Just give it a try. Okay. You test LG and test LN.
Yeah, I got the same result.
Right. So for some reason, this thing seems to work, right? For some reason, right? But I haven't shown you a proof why this is now the same as that. So I might remember this wrongly, but in your fancy graphing calculator is TI-84, right?
Right, let me take it out.
Is it correct? Is TI-84?
Is Texas Instrument TI Inspire TX2.
Sorry, TI what? Sorry.
Let me take a picture.
Sure. With the not the brand, the model.
Yeah.
Okay, this looks new to me. TI CX2. Now, what I'm going to do is I'm going to look for a look at your look at your button like next to 1. You also see the ln and the log, right?
Yeah, I see.
It's not a coincidence that below ln is e to the power of x, and it's not a coincidence that below log is 10 to the power of x. That means that the base of the log is also 10, no? The base of the ln is e. It's not a coincidence.
Yeah.
Right. So what I want to find, because I'm not familiar with this model, is whether this model can do log base another number. So I'm gonna search that a while. So this is ti, I suppose cx2.
I can test the calculation if you wish.
You can what? Sorry, you can.
I can test out whatever you want on the calculator.
Give it a try. Meaning you have to be able to find the menu lah. Is there a menu to change the base, right? Okay. Please give it a try while I also search for it.
Yeah, you can change it.
You can change. So for example, you can now type log base 2, 5 in your Calvin calculator. You can. Okay, please do that. Log base 2, 5. And what is the answer? And please compare it with our simpler calculator.
2.32.
So
Yeah.
is it the same? Is it the same?
Yeah.
So the first law, which is called the base change law, you don't know why it works, but it works.
Yeah.
And the first usage of this law is to bypass your simple calculator's limitation.
Yeah.
You will need this in many other examples also, not just to bypass the limitation, but here you go, the first law, okay?
Yeah.
This is super abstract, but I hope you can accept and later apply. Any questions or what?
Yeah. I mean, sorry, no questions.
Right. I'm going to show you the second law, and then I'm going to stop there first. First law and second law, still quite simple, also a bit abstract, but please follow me to the page 6. So second law of logarithm. Give me a random number.
3.
All right. Give me another random number.
4.
And finally, one more random number.
7.
So 7, is it? 7?
Yeah, 7.
Okay, 7. So I am claiming I'm claiming. This is the power law or the Indice law. So it has something to do with this guy. This is what the second law is interested in. I would like to highlight that I will just say this is what the first law is interested in, correct? The base change, meaning the base of the logarithm, right?
Yeah.
This is the base change. This is the second law, which is the power law. Again, because it's addressing the 7. Now I'm claiming that the law allows you to do this. 7 times log 3, 4. That's the claim. What happened to the 7? The 7 can exit, if you so wish, or the reverse is it can enter. You don't always want to exit, you sometimes want to enter. He can do both.
Okay.
Right? So now I'm going to ask you to prove that this is correct using your fancy calculator first. Okay? Fancy calculator.
Okay, we're going to do it. Log 3.
Yep. Of 4 to the power of 7, right? Is it the same as that?
Give me a second. I'm not very used to this.
Yeah. The fancy calculator is always like that. So take your time.
Yeah. Where's power?
It's good to get used to it now. Let me see the button. Maybe I can help you.
I can't find it.
The button should be, wow. Wait, it's so weird that you don't have it, like it cannot be, right? Yeah, it's so weird. So just try the 10 to the power of x and change the 10. That's so weird, but try that.
No, there's definitely a power in some. I don't think it's.
Yeah, so you can do that route. You can press 10 to the power of x and then just change the 10. Alternatively, you can press x squared and change the 2 also. You can do both.
No, this is fine.
Yeah,
Well,
it's
when are
weird.
your props coming over? Because I think it'll be quite useful. Because you'll be able to see what I'm doing.
Sorry, you're saying what? Sorry.
What are the things you ordered coming to my house? Like, is there a delivery date?
Oh, yeah. That thing will be useful. Yeah, it's at most 2 weeks from now, at most. So I'm expecting it to be faster, like 1 week.
Okay.
Yeah,
it's the same.
Yeah, you're talking about the phone stand, right? The handphones.
Yeah, the handphone set. Because now
Yeah.
with that you can see what I'm doing in my calculator.
Oh yeah. I strongly wish for that. Right? True.
Yeah.
True. Yeah. So, but we'll do what we can for it.
Yeah.
Okay. Now, if you cannot, just tell me. Okay, we're gonna just use the simple calculator.
Yeah. Yeah, but I got it. It's the same. 8.83.
Right. So you have proven that this is the same as that. Am I correct? This is the same as that.
Yeah, it is.
All right. So just to test whether you can, again, this law is weird, right? It seems to kind of out of nowhere, but you can see how it works. So give me a random number.
6.
Right, another random number.
2.
And then one more random number.
5.
According to this power law of logarithm, what can you do?
I can do 5 times log to the power of 6. Log base 6 power of
2. Yeah, please just confirm this. That is correct using a fancy calculator, and then we'll try to use the simple one.
Okay. Log of 6. Yep, they're the same.
All right. Now, here's a challenge for you, right? This is a second law. You know how it works, even though it doesn't seem to make a lot of sense. But at least it's correct, right? You can prove it to yourself in case you forget in exam using your calculator. Now, how do we prove this? Here's a challenge. How do we prove this using your simpler calculator? Is it possible to do that?
No, right? Because we can't change the base.
Oh, but you can using the first law. So what must you do? You cannot use log base 3 in your simple calculator. So you must base change to log base 10. And what do we have here? Again, it's
4 to the 7.
Very good. Yeah. You kind of remember how it works. And then over log base.
It should be log base 10, 4, and then the below one is 7.
No, here, like that. Again, it's abstract, right? It's not very clear how it works, but this is how it works. You put this guy, this whole package on top. You put this guy in the bottom. You can check page 5. Yeah, the whole package. That's how it works. That's how it works also in the page 5. So I'm going to put it very clearly that, let's say this is 5 to the power 1. Let's just put it that way, 5 to the power 1, something like that. Okay. So again, it's weird, but that's how it works. So how do we change the right-hand side? The right-hand side will be?
It should be 7 multiplied by the one on top, basically, log to the 3.
Log base 10. Log base 10. What?
Log base 10. Oh. 4?
Base change. Yeah. That's how it works. Log base 10 over log base 10 3. Yeah, again, it's weird. It's abstract, but that's how it works. So give it a try in your simpler calculator. You'll find the typing faster, I think.
Log 8.83 and 7 multiplied log 3. Yeah, this is it.
Yep. So again, I apologize for the abstract nature of the law. I promise that it will be useful, but right now, this is both the first and the second law.
Yeah.
Any questions so far?
No questions.
So the third and the last law. So this is foundation for the third and the last law will deal with this guy. So we are fair, right? The first law deal with the base of the law. The second law deal with the power of the inside. The third law deals with the guy here, the position of the form. Okay, so let me show you what it means. Right. So the third law. Logarithm, let's say base 2. Okay, let's say 12. Now, it goes without mentioning that 12 is 12 to the power 1, but 1 you don't need to write. Okay, so 1. Okay, I'm claiming based on the third law that this will be equivalent to 12 is 6 times 2. Yes, put it that way. No, never mind. I'm going to use 3 times 4. Easy. 12 is 3 times 4. Yes. 12 is also, for example, 24 divided by 2, for example. Okay. So I'm claiming for the third law that this is log base 2, right? 2. This is going to be 3 plus log base 2, 4. Also, it can be treated this way. Log base 2, 24 minus log base 2, 2. This is gonna be very weird, but 3 times 4, log base 2, 3 plus log base 2, 4. 24 divided by 2, log base 2, 24 minus 2.
Plus minus signs in the middle of the logs are acting like multiplication and division signs respectively in
something like
powers.
Yeah, something like that. You see a very similar trend in indices. Division becomes plus, division become minus, times become plus, something like that. Something like that. Okay, now this is the third law. This is the third law. Okay, now let's give it a try, and that's the end. Super abstract already. Then we can apply already. Now, give me a random number.
5.
All right, another random number, but kind of big.
16.
Okay, 16. That's nice. All right. So apply this third law in its two forms. You can have something plus something. You can also have something negative something. I'm gonna write down what you want to do. So how does it go?
Okay, so it goes log 5.
Yeah.
4.
Sure.
Plus log 5, 4.
Yeah, works fine. If I change this to 2, can I do that?
Yeah, then you can do 8.
Yeah, looks fine. Really, that's great. Okay, apply the negative aspect.
Should be 32.
Sure.
Minus 2.
Right. Now use your simpler calculator, prove this one and prove this one. And then that's our introduction.
Let me change.
Oh yeah, it should be 5. I'm sorry. Yeah. Excellent. Excellent.
Okay, so log you mean testify this on the fancy one, right?
No, the simpler. I mean, you can go the simpler one immediately, but you can go the fancy one also. Either one.
I'll do that.
Yeah. As long as you know this is not just out of thin air. As long as you know. There's some way to justify this.
Log 5. Minus log 5. Yeah, okay. They're all the same. 1.7.
Yeah, right. So I promise you, this is the last of the law. Rule one, law one, law two, law three. Law one, let's agree, is called the base change. Law two is the power law, and law three, I don't have a name, but that's law three lah. Your teacher may introduce them in a slightly different order. It's gonna be these three law. Okay. Now we have 10 more minutes, and I'm going to simply apply it in front of you, so you have an idea and a taste of how it goes lah. And to do that, I need to get a logarithm question.
Speaking of it, seeing that you won't be teaching me for a week, can you give me some homework?
By
homework, I mean just base questions, like very basic questions, like this, what you're doing right now. So I can just, be able to, by practicing it, I'll be able to.
So you're saying that you don't have a textbook that contains the basic question. Am I correct? That's how SGI works.
I believe this is A math, right?
This is a math textbook if you have it, I suppose.
Oh, I'll practice for A math, but that's my dad bought it, and it's mostly filled with like higher level questions, which I haven't gone through yet since we're doing the basics.
Sorry. What did your dad bought? What did your dad bought? Your dad
bought A-level math. I mean A math textbook.
A textbook, right? Okay.
Take a picture. Like workbook with.
Take a picture. You go to that. I just want to know the level. So you go to that workbook and you go to the logarithm chapter if there is, and just take a picture of the first logarithm page. Okay. Mm-hmm.
Sorry it took me so long.
No problem.
Yeah, logarithms. Oh, let's have just exponential and logarithm functions.
Sure. Take a picture of the first page. Let's see whether there's a logarithm question. If not, then we'll venture further.
Okay, these are the very first questions. Very first few questions.
Just the very first. All right, so let me just see. Yeah, they're not basic. They are not exactly the most difficult one, but they're not basic. And this is only in this is in this question. Could you flip and try to find logarithm question because they are very obvious.
Yeah, there is one.
Okay. Take the full page picture. Right. Let's see what we're dealing with.
This is all the basics. We did
right. Yeah. If I were to discuss with you in this basics, you could have done question 1, 2, and 3 and 4 perhaps, and 4 you could have. But today we discuss logarithm, so no worries, huh? There's no worries.
The picture's a little bit blurry, so maybe you can't see.
I'm sorry, you're saying?
I sent the picture.
Right. Okay. No problem. Okay. So, yeah, these are okay. So clearly from question 11, you can already see that it is a logarithm question.
Yeah.
Okay. So I'm gonna, 11 is basic. So I'm gonna practice 11. I'm gonna show 11a in front of you. Your job is to identify whether I'm applying any law or not.
Okay.
Okay. So question 11a. So I'll leave 11b for you lah.
Okay.
Notice that in 11b, you have LG. You now know what it means. What is LG?
LG is the log E, right?
Base 10. No. LN. That's LN. LG is log base 10.
Oh, yeah.
Yeah, LG is log. So as promised, that is what your teacher will be doing. So only A for me. Yeah? So the question is for you. Am I applying any law? I want you to recognize whether I'm applying any law. So the law will be called base change, or the power law, or the plus minus law. Okay. Yeah. So am I applying any law? Right. So I see this. Now I'm very happy with the fact that this is base 3, and base 3. If the question all base are the same, this is going to be easy. Now this is principle already. This is principle or experience. Experience says if my questions base are all the same, I'm in for an easy ride. If the question base is base 10, and base 4, oops, I need to do some work. Okay, oops, just a slight work. Now this one, easy. Why? Now, did I apply any law?
No.
Yes, I did. Base change,
yeah.
or
well,
no, cannot be, because my base did not change. Right? My base did not change, so cannot be. How about the power law? Did I shift any power in or out? I did not, right? I did not.
No, you didn't.
So not the base change law, not the power law. I'm left with the third law, the positive or negative thingy lah, which has two forms. Recognize that I'm using that law. Recognize it. If you cannot see it, tell me.
Yeah, I don't see it.
Okay, let's go back to page 7, right? Page 7. Now, recognize that every law has two directions, right? I can go like that, or I can go like that. So I can go from this to that. And of course, I can also go from this to that. Correct?
Yeah.
So I'm giving you a hint here. Am I going from left to right, or from right to left in page 8?
Or from right to left?
Yes. Do you see it? If don't, please tell me.
Yeah, I don't.
Okay, go back to page 7. Go back to page 7. So in page 7, I have this one, log base 2, 3 plus log base 2, 4. I noticed that this base and this base is the same. Did you notice that?
Yeah.
I'm very happy. Because that's a requirement to apply this law. I cannot do it if this is base 2 and this is base 5. I cannot. Okay. Yeah. So base 2, great. I will make this 2 guy become 1 guy. Log base 2, 3 or plus. Okay, great. So I'm going to put in here 3 times 4.
Oh my God.
Do you see it? I mean, it's weird. It's abstract, but now you see it.
I thought you were summarizing just the first part, log 3 to 4.
No.
Yeah, I definitely see it now.
Okay. Now you can see the attraction of this log. I just combined 3 logarithms into 1. That's attractive. That's simplification. That's just like in this. In this, if you know the in this rule or law or whatever that is, you can simplify things. So I'm going from right to left. Yes?
Yeah.
Now, he asked us to not use a calculator, so time to test your mental calculator, right? Now, can I divide 3 to 4 divided by 4?
Yeah, probably.
What is it?
I have to use a mental calculator, right?
4 divided by 4 is?
1.
32 divided by 4?
8.
Good. So logarithm 3, let's assume that is your exam, right? You can use calculator. So it's 81.
Yeah.
Now, how do we continue from here? Do we stop here? Do we continue? You have to use some judgment.
If it's the actual if it's this question saying without using a calculator, this is enough.
I'll show you more.
Oh.
I'm claiming that 81 is 3 to the power and you do not have an access to calculator. What is the number?
3.
No. 3 times 3 is 9, times 3 is 27, but you're close.
3 to the power 4.
Yes, because 9 times 9, which is 3 to the power of 2 times 3 to the power of 2, which is 4. Now, why is it important to change the 81 into 3 to the power of 4? Why is that nice?
Because you can cancel out 3 and then it becomes
Therefore,
4.
Yes. Now, this is not law. This is basic of the basics.
Yes.
Okay, so this is just basic, like that's not law, right?
Yeah.
Voila, I'm claiming that the answer is 4. If you now use your calculator, you can test whether it's 4 or not. So you have your first homework, Ainesh, your first homework is 11B. I would like you to take note that this is log 10, and this is not log 10. Be careful. You have to do something.
Okay.
You have to do something. You think about it. The question is already testing you in a deep level, I must admit. So it's good, right? So if you cannot do it, I expect to see effort. Maybe not the correct answer, but I expect to see effort. Now, time is up. I will assign you your first homework. It's 11B, right?
Yeah.
Okay, nothing is easy. I'm so sorry, Anish. Can you take the challenge? Nothing is easy.
Nothing's easy, yeah.
Yeah, so 12 and 13.
Oh, 12 and 13.
Yeah, and that should be really enough if you can do 12, 13, and 11B. Like really, that's enough for 1 week.
Okay.
I am expecting your teacher to cover slightly more than 13. Just slightly more.
Yeah.
I'm expecting your teacher to cover the law. My sense is that your teacher has not covered them, the 3 laws.
Yeah, I don't think so.
Okay, so that's the expectation. The law, and then the not the most difficult question, which is 11B, 12, and 13. It's difficult enough for you right now.
Yeah.
Okay. Time is up. Is there any other question first, Ainesh?
Yeah. Firstly, can I, like, for example, if I have any queries, right? Am I allowed to text you outside of lesson?
Yes, you can. You can.
Okay.
So usually I will reply very quickly, but this week is a busy week. So just send me the question. You know what? Don't worry whether I'm busy or not. Send me a question. So at least I know you have this problem. Oh, okay. It's a good problem. I want to talk to you about that when we need something. Okay. So text me whether it's my homework or whether it's other topics or it's a school. Text me.
Okay. Sounds good then. Also, you said you teach chemistry and physics. If I do have chemistry and physics issues,
yes, you can ask them. Now, here's a consideration. Here's a consideration. AMAT is the most effort-intensive subject.
Definitely.
Right. And you're catching up, right? So I'm assuming that your chemistry and physics are in a better shape. Now, you can ask physics and chemistry questions. There's no problem. There's no limitation. But the effort to catch up for AMAT will require like most of our tuition time.
Yeah.
That's the limitation. The limitation is not that you can or cannot ask. You can always ask. The limitation is the focus we have.
Yeah.
But you can ask them. You will see other students asking them from time to time.
Then what about outside school? Sorry, outside the tuition session.
Oh, you mean WhatsApp, right?
Yeah.
I just send them.
Okay.
Just send them. So I will either, because usually we'll meet very frequently, you realize. So for example, the normal timing is Sunday, Tuesday, Thursday, right?
Yeah.
So whenever you send, like I'm going to answer you like either tonight or tomorrow night. It's just like that.
Yeah.
Right. So don't think about it. Just send first.
Yeah, okay.
Okay. All right. Anything else?
No.
right? So for this week, that's my homework for you, and and I hope to see you next week.
Okay.
All right.
Can
Take
you
care,
call my
Ines.
dad?
You're
Should I
saying?
call my dad like we did last week?
You're saying? Sorry, you're saying?
Should I call my dad like we did last week?
Oh, no. That's fine. Of course, if you want your dad to talk to me, that's fine. But no need. There's no need if there isn't. If there is.
Okay.
All right.
Goodbye. Have a
I'll
good
see you,
night.
Anish. Bye. Good
Bye.
night.